Hello and welcome back. Higher Maths Differentiation, equation of a tangent. We're going to look at a more complex example. Not more complex because the overall strategy changes, just more complex because we have some fractions and negative numbers involved. So the method is going to be exactly the same as examples 1, 2, and 3. We are going to find the gradient of the curve when x equals -8. We are going to find the y-coordinate as we're not given it, and then we're going to find the equation of the line using y minus b equals m bracket x minus a. So let's find the gradient. So we have y equals the cube root of x squared, so top number is the power, bottom number is the root, so that we can write that as y equals x to the power 2/3. So now I'm going to differentiate, so I write dy dx, and then I'm going to bring the power to the front and reduce the power by 1. So that's 2/3 x to the power -1/3. Remember, 2/3 minus 1 whole is 2/3 minus 3/3, which is -1/3. And then as I'm going to substitute in a number into a negative power, I am definitely going to rewrite that to avoid any mistake. So the negative power means it should be on the denominator. The power 1 means it's x to the power 1. The 3 on the bottom, the 3 is the denominator, means it's the cube root. So that's 2/3 multiplied by the cube root of x. So at this point, I'm going to substitute in. The cube root of -8 is -2 because -2 times -2 is 4. Multiplied by -2 again gets us to -8. So then here we can either simplify the 2's first of all, or we can do 3 2's are 6 and 2/6 are 1/3. And of course, we've got a negative sign there as well, so that'll be -1/3 for the gradient. So dy dx, when x equals -8, is -1/3, which is the gradient of the tangent to the curve. The y-coordinate, remember the y-coordinate is always given by y equals, okay? Y is the y-coordinate, dy dx is the gradient. So y equals the cube root of -8 squared. So always do the cube rooting first. So the cube root of -8 is -2, still got a square there, so we get +4. So our point is going to be -8, 4. So it's a more complex example, but only more complex because we have fractional indices or fractional index, and the manipulation involved is slightly trickier. Okay, but we are following the same strategy every time for this. It is find the gradient, find the y-coordinate or the x-coordinate if necessary. Like in question 3, when we were given the y-coordinate, we needed to find the x-coordinate. And once we have the point, a point on the line and the gradient, after that we use y minus b equals m bracket x minus a. So here, substituting the values, I'm going to multiply both sides by 3. So 3 bracket y minus 4 equals negative bracket x plus 8, or I've just multiplied through by -1 in one go there, guys. So -1 multiplied by x, -1 multiplied by plus 8 will give the minus 8. So expand this bracket, 3y minus 12 equals -x minus 8. And then add 8 to both sides. Sorry, add 12 to both sides, I should say. 3y equals -x plus 4. So remember, when doing a straight line question, we can write our answer in the format of y equals mx plus c. Or we could write our answer in the form of ay equals bx plus c, which I've done here. So rather than having a fraction in the answer, I've gone for all whole numbers. I could also write this as 3y plus x equals 4, which is totally acceptable. Or I could write 3y plus x minus 4 equals 0. Or as I said firstly, I could divide every term by 3 and have y equals -1/3 x plus 4/3. Now, any 4 of those formats are acceptable final answers in the final exam. So if you have an answer when you're working through the exercise, and it's not exactly the same as the one in the back of the book or exactly the same as mine, have a look and see if you can rearrange yours, because the chances are you have the right answer, but in a different format.